Good evening and a very warm welcome to everyone. Today marks the final session of the first phase of our inspiring journey with InspiHER Tech V2.0. This is a place where your thirst for knowledge kindness and your talents shine bright. I am Imanka Sandarenu, signing in as the moderator for the day. Let's band together to boost the aspiration of our talented female undergraduates and the bright spark of the younger generation as we forge a path towards success and skill development. Now let's dive into our agenda without delay. Today is the last day of our MATLAB workshop series. This session is based on topic Introduction to Machine Learning, which will be useful to complete the final task. Moving on with events proceeding, we have our esteemed guest speaker to conduct the session. Please join me in extending a warm virtual embrace to Mr. Pramukha Veerasinghe, the distinguished lecturer from the Department of Statistics and Computer Science at University of Peradeniya, who will helm today's session. Mr. Pramukha Veerasinghe, the virtual podium is all yours.
Okay, so thank you. We'll start. Welcome all of you to this final session on machine learning. So let me share my screen first and we'll get started for today. Okay. So, yeah, I think you can see my screen. Can someone please confirm if you can see my screen properly?
Yes, sir.
Right. Okay, thank you. Right, so we'll start. So today is basically going to be an introduction to machine learning. Before going into the practical component of things, I'll basically be covering a few things today. So if I just briefly tell you what I'm going to cover today, I'm just basically going to cover, first of all, I will just explain to you what machine learning is in a very brief manner. And then I'm going to basically tell you how to set up your environment in your local machine to basically do machine learning tasks. And thereafter, I will introduce to you a cloud service, which is very popular these days for machine learning and deep learning tasks, which is basically provided by Google, called Google Colaboratory or Google Colab. Maybe most of you might know it already, but I'll just give you a very brief introduction, and then I'm going to basically go dive into an example of a basic machine learning example, which is a regression example, and show you how machine learning works. And so yeah, you can get a basic idea of what happens. Okay, so we'll get into the content. So machine learning now, it's been used a lot these days and for quite a long time right now. So basically, if you think about machine learning, and it's just a small part of AI, it's about a sub part of artificial intelligence. Basically, when you take artificial intelligence based applications, you can break it down into two types called machine learning and deep learning. So basically, these days we are more interested in deep learning tasks than machine learning because of the complexity of data that we have. So if you take machine learning, it's basically what we do here is any machine learning or deep learning or any artificial intelligence based task, we do a couple of things. What we try to do is we try to make a prediction on data. So we try to take some data and then we try to predict something with that data. So what's the difference between a normal application and a machine learning application would be is that in a normal application, you would be giving all the inputs and you will be getting an output. Then you'll be doing all the processes manually, you'll be programming everything and giving the instructions to the computer manually. But in a artificial intelligence based application or a machine learning application, what you will do is you'll just basically be building kind of something called a model, which is kind of a mathematical model and something that do with the data that you already have. And after you kind of build the model, you're not going to do anything again. You're not going to like program again. You're just going to use that So the model by itself will make a prediction on data after it has learned some features before. So what you're doing is you're just going to make a model and you're going to train this model on some kind of an algorithm. And when you do that, what happens is it learns from data. So you'll have a data set. Basically, you start with some kind of data. It learns from those data. And then finally, what happens is after it learns something, it can predict some outcome for some unseen data, for some new data set or some new example. So a common example, as I explained earlier, would be, let's say you have an application there, you recognize cats and dogs. So what happens is you give an image of a cat or a dog, it recognizes it as a cat or a dog. So if you want to build an application like that, what happens is you basically start with a data set having cats and dogs, and then you will basically train this data on kind of an algorithm, and then you extract the features from cats and dogs, and then this algorithm basically learns the features of cats and dogs. And after it learns these features, and after it achieves a certain level of satisfied accuracy, for example, somewhere around 70 or 80% accuracy, these are many things that we have to discuss, like there's the accuracy factors, how you can deal with this accuracy, how you can basically change parameters. These are a bit, when you dive deep into this lesson, you have to learn a lot of things. But as a basics start, let's just say, okay, you want to basically build a model with a high accuracy. So then let's say, so you learn the features from cats and dogs, images of cats and dogs. And what happens is after you do that, you provide this algorithm, or this we call in the model, with a new image that it hasn't seen before, right? So an image of a cat or a dog. So what happens is when you provide that image from what it learned before, the features that it learned before, it will automatically recognize this new image as a cat or a dog. So that part is done automatically. So that's how it does it do it. It basically learns from the previous data and it makes a prediction on future data. So that's basically what happens in machine learning or any deep learning application or algorithm. So what we do in machine learning is we start the data set and then we try to train, we learn something from that data. And after you learn and you build some kind of a model, we use that model to basically predict some new data. And that's what happens in any machine learning or deep learning algorithm. So everything that you see, these days with all these algorithms is basically done using something like that. So if you take the most common application right now, which people, I think everyone uses, ChatGPT, it falls into a category called generative model or generative learning. So generative models are basically a kind of models which can generate new data based on what it has learned before, right? So we call these large language models, which basically are to do with lot of language based data sets. So it has a lot of data based on languages. So what happens is when you ask questions, all these questions become kind of a data set for the model. So what happens is there is a mapping between questions and answers. And once you ask a question, it's able to map that into a specific answer and give you the output. So whenever you ask new questions from ChatGPT, it basically trains itself to basically learn those things again and again. And once it answers the question the second or third time, you might see sometimes it gives much better answers because it has learned from the previous questions, and then it basically will give you much better answers. So you have a large data set in ChatGPT, a large data set having a lot of questions and answers, and it will have kind of an algorithm that maps all these questions to the appropriate answers. And that's how basically it's kind of in very simple terms, that's how ChatGPT works under the hood, right? But there are other things that you have to learn more on that. But just to start off and maybe to understand what this is all about, that's how it happens. So we will do something similar. We are gonna like start from a data set and then we'll learn some features and then we'll predict something thereafter. That's what machine learning is all about, right? Predicting something from data by learning its features. That's what happens, right? So let me dive into a simple example for you to understand this much better. So this is exactly what we are going to do today as an example as well. So I think you're all familiar with graphs now. I think that you are all with graphs. So let's say this is one of the most common examples that people normally take when they talk about machine learning examples. So let's say you have, let's say you have a graph. So let's say you have the prices of houses, right? House prices, right? And this will be the house price in the y-axis, and in the x-axis, let's say you have something like, say, for example, number of uh, resources, or let's just take something called house type or something. Let's say house type. So what do I mean by house type is you can have a single storied building, you can have multiple storied buildings, you can have houses with balconies, you can have houses without balconies, different features, right? So based on the type of house, the price of the house will vary. So that I think you can understand, right? So what we do now is we'll have kind of a data set which already have different types of houses. So we'll say we have houses called A, B, C, and D. So we have a data set with us which already has houses A, B, C, and D, and also the corresponding price of all these houses. Let's say this is, so just for example, right? You won't get houses for this price, but let's say 100,000, 200,000, 300,000, and 400,000, something like that. Okay, so you have houses of different prices, right? So what you have right now is a data set with you with houses A, B, C, and D, and also the prices of all these houses, 100, 200, 300, the corresponding price. So what we're going to do right now is we're going to map these two variables, house price and house type. We're going to try to make kind of a relationship and see how these two variables correlate with each other, how they relate with each other. So what we're going to do is we're going to basically have a mapping. So for example, let's say this is this. So you'll get different types here, right? And for now, for example, I just do this. So let's say you have these kind of a mapping, and what you're going to do is you're going to try to find a line that basically fits through all these variables, the best fitting line. And if you can find the equation of this line, right? If you can find the equation of this line, you can find the equation of this line, then what means using that equation, you are able to basically predict any house type and any house price. I think you can understand that because if you understand the mapping between the house price and house type, let's say I have a new house called E somewhere around here. Let's say a new house called E. Then I simply, if I have the equation of this line, I can simply map it and find what is the corresponding price, right? So we are going to train our algorithm, whatever machine learning algorithm. There are many algorithms. So for now, just think of it as just an algorithm. So we are going to use some machine learning algorithm, and we are going to train our data to find the mapping between house price and house type, which will be the equation of this line. Once we find that equation, we are able to predict any house type and the corresponding price for that house. That part is done automatically. So then when you just enter the house type, it will give you the house price automatically. So that's a very common basic example of a machine learning application. So this is something that we're going to do today. So this kind of a application, this type of machine learning algorithm is called a regression algorithm, right? It's called a regression algorithm. So what do you mean by regression is it's a regression algorithm. So a regression algorithm is an algorithm, basically it's basically going to predict data on continuous data. So this is going to predict some results on continuous data. So you can see this data is continuous, it's not discrete. You can have any number of houses, you can have any and corresponding any number of prices. So it's kind of a continuous type data. So whenever you have continuous data, house prices, salary ranges, it's a stock market prices, different kinds of data which has continuous type data, you can use regression algorithms to basically do a prediction. So that's one of the common machine learning algorithms out there, which is a regression, right? So it's a statistical algorithm actually. So this is what we're going to like basically do practically today to understand machine learning. And there are other things called classification tasks. So I hope you could understand what regression is right now, right? Simply predicting, finding out the correlation or how the two variables depend with each other, X and Y. You find how they depend with each other, you find the equation of the best fitting line, and then you try to predict for a new result. That's what happens. Okay. So this is the most common type of machine learning algorithms out there. There are other algorithms called classification algorithms. So the difference between a classification algorithm and a regression algorithm is this. So first I'll tell you what classification algorithms are. So I think this is, you've got an idea of what regression is. So I'll quickly go to classification and tell you what that is, right? Okay. Okay. Right. So classification is something like this, something like what I said earlier, the example. So you have an image, a data with kind of an image, right? So you have an image here. What you're going to do is you're going to send this image to a kind of an algorithm, a classification algorithm, a machine learning algorithm. And what that algorithm is going to do is, if it's a classification algorithm, then it's going to classify this image into one of two classes, either a cat class or a dog class. So that's one thing. So if you have discrete data, not continuous data, discrete data, so you have only two classes, either cat or dog. So it's once you give an image, it's going to basically classify this as a cat or a dog. So this kind of problems are called classification problems, where you basically classify your data into a certain class. There can be one single class data, which you call a single classification algorithm, or you can have multiple classes. You see multiple, so multi-class classification. So you have multiple classes. So if you have, this is like a multi-class classification problem where you have two classes. You can have two or more, right? You can have many classes. So you can classify your data into multiple classes. So if you are basically classifying data into multiple classes, those kinds of problems are called classification problems, right? So I think you have to understand the difference between regression and classification. So regression is basically doing some prediction for continuous data, and classification is doing a prediction for discrete data. You classify into classes. So I hope you got the idea of what classification and regression is. The reason I explained to you these examples is because these are some of the most common and basic algorithms that you have for, right. So we'll start on the next part. So I hope you got an idea of what regression and classification is. So I kind of found kind of an image that could kind of explain to you exactly what this is, the difference. I think now you already understood the difference, but this image kind of tells you the story. So it's like this. So a regression is you can predict the temperature of a day. So when you give a day, it can predict the temperature. So when you say day and temperature, you know, these are continuous data, right? You can have multiple days, you can have different values for temperature. So it's continuous. So if you predict something like that, those kinds of problems fall into regression. But if you kind of classify into one of two classes or multiple classes, either the temperature is going to be hot or cold. It can only be either hot or either cold. Those kinds of problems will be called classification problems. So I think you understand the difference, right? If it's continuous data, it's called a regression problem. If it is discrete data, it's called a classification problem, right? So that's basically the difference between regression and classification. These are two common machine learning type algorithms, right? Okay. Right. So before we start on our example, let me tell you how to set up your computer or your environment for machine learning. So first of all, when you start off with machine learning, one thing you can do is, now I think I in the last session I kind of gave you a brief idea on how you can use the Python package manager to install libraries. But the way I showed you earlier is to go to the installation directory of Python and then go to the scripts folder and then install the libraries inside that scripts folder. But if you are doing machine learning tasks, that's not the best way to do it. The reason is, now when you go to do machine learning projects, sometimes all these libraries will have different versions. Even Python has different versions, right? You have 3.6, 3.8, 3.11, many versions. So depending on the type of version that you want for a certain project, you might require multiple versions of the same library, right? For example, you might require different Python versions for different projects. But if you install all these versions in a single place in your computer, that's going to have a conflict, right? A version conflict. And then when you work on these things, it might give you errors, right? So you normally don't install all these libraries into a single place, into your computer. For that, you kind of install a third-party library manager. We call it a package manager, just like Python package manager. You have another package manager called Anaconda, right? So that's a very common package manager which people use when they work with data science or artificial intelligence applications. So first of all, download this ma package manager called Anaconda. It's freely available. So you can go to the Anaconda website and then freely download this. So after you download, you'll get certain programs installed into your machine. But just remember now, this Anaconda is a kind of a little bit of a heavy software. It takes a little bit of RAM, and you'll need a good kind of a machine to install this, but it will take a lot of RAM. So if you do not have enough resources in your computer, once you work with Anaconda, it can be a little bit slow. So for people that has less resources in their computer, less amount of RAM, less amount of disk space and things like that, less resources, a less powerful computer, you can install the lighter version or lightweight version of Anaconda, which is called Miniconda, right? So I know it could be like something funny, Anaconda, Miniconda, these are just names. So this is basically a package manager for libraries that you work when you work with data science based applications. So for people that has less resources can basically install Miniconda, right? So that's also available. So for people that don't have Anaconda, high performance, powerful computers can go for a Miniconda, right? So this has less features than Anaconda, but enough features for you to start off with machine learning and deep learning applications. So you can install either one of these, right? So after you install Miniconda or Anaconda, you get a command prompt terminal, right? Called the Anaconda prompt, right? So you go to start menu and just type Conda and it will basically come, or you can type Anaconda, it will come, right? So you have the Anaconda prompt here, right? So when you just go to start and type Anaconda, you get the Anaconda prompt. It's just a command line, just like the Windows command line. So go to that and you'll have a very similar kind of a command line interface, just like the normal Windows command line interface. So why do you use this is because now why do you use Anaconda or Miniconda is what you can do is you can create something called a virtual environment for each of your machine learning projects. What do you mean by a virtual environment is you're going to create an arbitrary environment where your projects will be basically encapsulated with different resources and different libraries. So what you can do is you can create a virtual environment for a certain project and install all the libraries to that virtual environment. So what happens then is now, unless what you do normally is now, so normally what you will do is you'll install all the libraries into your computer. So if this is your computer, you'll install all these libraries into the computer here, into your normal machine where you have installed Python, right? When you do this, what happens is if you want multiple versions of the same library, for example, if you want Python 3.6 for some project, and for the other project, if you want Python 3.8, then it will be a conflict, right? So when you want to do this, what you do is you create something called a virtual environment in your computer. So it's like a container. So you have a virtual environment here. Now, when you have virtual environments, these virtual environments are independent of each other. There's no dependency between this virtual environment. So you can create a virtual environment for a specific project, right? So now I have a virtual environment for project 1, another virtual environment for project 2. I can install Python 3.8 to project 1 and Python 3.6 to project 2 or whatever. So now there will be no conflict in the libraries because they are separate. They're not depending on each other. So to create these kinds of virtual environments, we use this package manager called Anaconda or Miniconda. So this is why we use this. So I'll show you how to use this and create a virtual environment, right? So to start, you can see all the virtual environments that are currently existing in your computer. So when you first install Anaconda or Miniconda, you will not have any virtual environment because that's when you start, there will be empty. You'll have one virtual environment called the base virtual environment. That's the thing that you start off. The starting virtual environment will be the base. You can create many virtual environments. So to list all the virtual environments that are currently in your computer, you can use the command conda env for environment list. Conda env list. So when you give that command, it will show you all the virtual environments which are created on my virtual environments in my computer right now. So you can create similar virtual environments, right? So to create a new virtual environment, the command is conda, right? Conda create -n, and then name of the virtual environment. You can give anything. So let's say new environment, and then you can say what Python version you want for this virtual environment. If you don't specify the version, it will install the latest Python version for your virtual environment, right? So that's very easy to create a new virtual environment. So the command is conda create -n, say new, and name of the environment that you want, and you can give the Python version. So once you run this command, you can see it'll install some base libraries, and it'll create the virtual environment for you, right? It'll take a little bit of time based on your computer performance, and then you can see it'll create the new environment, right? We'll see. So it's currently creating the environment, right? Okay. So you can create separate environments for your separate projects, and then you can basically work and you can install multiple versions of the same libraries for different environments, and it will not be there will be no conflicts in those environments when you do that, right? So it's still creating the environment. We'll see. So this basically will create computer performance. So as you can see, they are asking me, okay, they are going to install some base libraries for you. So whenever you create a new environment, they will automatically install these libraries for you. And then they are, so if I want to proceed, they say you can just press yes, Y, and then it will install all these libraries for you, right? So yeah, so it's installing, right? So right. So depending on the size of the library and type of library, it will take different amounts of time to install these libraries. And we'll see, right? So it will keep installing this, and then it'll create the environment for you, right? So it'll create the environment. So until this basically works, I'll show you how to activate an environment. So once you create an environment, it'll keep creating like this. So once you create an environment, you'll see when you run this command conda env list, you can see that new environment will be created here, right? And after you create that environment, you can simply activate an environment to go inside the environment, right? So you can activate any environment here to start an environment. And then once you activate an environment and then install the appropriate libraries, those libraries will be installed to the particular environment, right? So not to the computer, but to the environment itself. So you can basically do that, right? So here, right. Okay. So let me show you that part. I think I'll have to wait until this installs. You will just wait for a few minutes and see what happens, right? So it will currently, so until this installs, I'll briefly tell you about the cloud platform that you have for machine learning, and I'll introduce that until this installs. Okay, so we'll go to that. Right. So basically, when you work with machine learning or deep learning or in artificial intelligence-based applications, the biggest bottleneck or the biggest problem that we face is the problem of resources in our computer. So unlike other tasks like building web applications, mobile applications, even those things can require different kinds of resources. But the problem is whenever you go for machine learning or deep learning based applications, you have to have kind of a computer with a good GPU or high number of resources, high performance computer. So normally our computers are not that powerful. There are powerful computers, powerful laptops available, which are very expensive. So one thing is you should have a GPU if you're going to work with machine learning or deep learning based applications, because otherwise it's going to take a very long time to run these algorithms. So for sometimes when you want to train a machine learning algorithm on a particular data set, it can take days or months even, depending on the resources in your computer. Therefore, you should have a kind of a high performance computer if you are doing your machine learning tasks in your own computer. So you should have a GPU. What do you mean by GPU? A graphics processing unit. So people, I think that basically play games might know this a little, because they kind of need that as well for different kinds of games, high performance GPUs. So what do you mean by GPU? Let me introduce that first, and we'll see what that is. So I think most of you might know already what a GPU is, right? So you know what CPU is, right? So in a computer, you have the central processing unit, right? Which do all the processors, the arithmetic and logical operations, and all the control operations in your computer. So you know what the CPU is. So what do you mean by GPU? So GPU is basically something like a CPU. It's like a processing unit that comes in built with your graphics card, external graphics card, right? So this is called graphics processing unit. So this comes basically, it comes with your graphics card, right? External graphics card. It comes with your external graphics card. So for you that you, for the students that don't know what this is, so I'll just introduce this. So what do you mean by an external graphics card is, now when you take your computer, you have two types of graphics cards. You have the internal or onboard graphics card, and you have an external graphics card that you can plug and remove. Normally, an onboard graphics card is not that powerful, right? You have this Intel HD for computers that come with by default. You have this Intel HD graphics card, which is not that powerful and not suitable for high performance tasks. So if you're doing high performance tasks, even if you're like editing videos, you're creating videos or playing some games which require high performance graphics, then you need an external graphics card. So there are many external cards available, but the most popular type of graphics card right now is it's basically called produced by the company called NVIDIA. So you have this NVIDIA graphics cards. So if your computer has an NVIDIA graphics card, that means your computer will have a GPU, because normally NVIDIA graphics cards comes with a GPU by default. So the processing unit in your graphics card is called graphics processing unit. So that to have a graphics processing unit, you have to have a external graphics card, something like an NVIDIA graphics card. So these days we have all these powerful NVIDIA graphics card. You might have heard all these GTX series. Now you have the RTX series, RTX 3080. There are many types of graphics cards available, right? So my computer is currently having a GTX 1050, which is not that powerful, but there are other laptops which has RTX 3080, 3070, which are very powerful graphics cards and has very powerful GPUs, right? So if you do have an external graphics card, that means you can work with these machine learning applications. Otherwise, it's going to take a lot of time to process, and it's very difficult to do it in your own computer, and it's not good, right? So if you're planning on doing a machine learning task in your own computer, it's better to have a good graphics card installed in your computer, right? But obviously, this is going to cost a lot, right? So laptops with external graphics card basically costs a lot, right? So if you do have this, you can work with uh, these tasks. So because these graphics cards are very expensive, it's not we might not be able to buy such high resource, high powerful computers. So because of this, now we have an ability of using a cloud service which gives you free graphics card resources, so GPU processing resources. So this is why this Google Colab, which I'm going to introduce to you right now, is very important. This is a cloud platform given by Google, which basically gives you access to free GPU service. So not that is a very a very good thing, because it's normally GPUs cost a lot, but you get a very powerful GPU free of charge when you use this Google Colab. There are limitations, although they give you all these things. There will be limitations when you are going to basically do very high performance tasks. Like if you are training with a very large data set, it can be a little difficult, but still, to do normal machine learning tasks or deep learning tasks, you can basically use this cloud service. So that is the importance of using Google Colab. So to go to Google Colab, just type colab.research.google.com. So colab.research.google.com. So when you go to that, you'll basically have kind of an interface like this. So when you start off, you might not see anything here, because these are the applications that I worked on earlier, but for you, it will be an empty part. So you can just go to new notebook, click on this new notebook button here to open a new notebook. So again, what do you mean by notebook? Now, last time I worked with some files which had a nice formatting of text and code when I showed you the Python examples last time. So I told you I'm going to introduce to you what that is. So, that has the ability of formatting text and code together. So this is also something similar. So what I worked on last time is called Jupyter Notebook, right? What the thing that you saw in my earlier session where I work with Python examples, it's called Jupyter Notebook. This is what Jupyter Notebook is, right? So this name has an interesting meaning to it as well, right? So this name Jupyter comes from it has come like this, right? So this is a platform that has been given to you to basically code different kinds of languages. So you can basically program different types of languages in a single environment using this Jupyter Notebook. You can also add text, you can add code, you can add both of those things together in a single platform. So this Jupyter name comes like this. So J is for Julia, the programming language called Julia, and PY is for Python, right? And R is for R, the language R, which is statistical programming language. So Julia, Python, R, all these are basically integrated together, and you can code either in Julia or in Python or R in this notebook platform. So it's kind of a very nice environment for you to code in different kinds of languages, especially in Python, right? So I'll just show you. So this is the Jupyter notebook that I worked with earlier in the last session. So I had already created some notebook files for you for Python. So yeah, this is, so you can see this is what I had earlier last time. So you can see you can add text and code together. That's the beauty of having a notebook. This is not a normal Python file. So normal Python file will have the extension .py. These are called IPython notebooks, right? This is the extension. You have IPYNB, right? These are, so you can see the extension here. You can see properly. So these notebook files will have the extension .ipynb because these are called IPython notebooks. So IPython notebooks means you have the ability of writing text and code together and format it in a nice notebook type format, so that you can see it's very nicely formatted. You can see the results here itself, right? You don't have to run the code and get a separate file. It will show you the output just below the code. So it's a very nice way of formatting your code. So this is called a notebook file. So you can use notebook. So to install this, you can just use the Python package manager and you say pip install Jupyter notebook, and it will install Jupyter notebooks, and then you can just run that to run the Jupyter notebook. This is an online thing I'm using right now. Last time I used my local notebook version, right? So this is very good platform for you to code in Python, right? You can just keep something like a notebook to refer later, right? So this is this same notebook environment is given to you in Google Colab as well. That's why it's called notebook here. So when I press on new notebook, it will open a new notebook for me, just like the Jupyter notebook that I showed you earlier, right? So it'll basically open a new notebook, and then you can work in that. So I'll show you the basics of that once it opens. So it'll open you a new notebook, and then you can basically start working on that notebook, right? Right. So when you first open Google Colab and when you open a new notebook, you'll see an interface like this. So there are some tools in the left-hand corner. You have blocks. We call them blocks of code or text. So this text can be either a coding block or a text block. So you can see here you have two types. You have code and you have text. You can either add code blocks where you can type a programming language, or you can add text blocks where you can just type text, right? So both are available. Currently, this is a code block, right? So I can just write some Python command and run and see. So to write, I'll just write a very simple Python command. So hello world, right? So this is a very simple Python syntax. So to run this, I'll just click on the play button, or you can press Control and Enter, the shortcut key in your keyboard, Control, Enter. So it will start to run. And once it runs, you can see uh, the output just there, right? Just below the code, which is very nice, right? So this is the beauty of this notebook style IDE. So notebook type platforms, you can just see the output below the code, right? You can also add text blocks here. You can add text blocks. So I can say, well, so these text blocks are basically markup type. You have these markup languages like LaTeX and other markup language. So you can just add some markup here. For example, heading one, let's say. So you can see I can add text. So see, this is a code and this is a text. So I can just format my text and code beautifully by using this notebook type. And the beauty of Google Colab is it lets you use other languages and other things other than Python, R, and Julia. You can also write HTML, which is very nice, right? You have the ability of writing all different types of language. For example, you have something called magic commands in Google Colab. So if you want to use some other language other than Python or Julia or R, you can use this magic commands. For to use magic commands, just type the 2 percentage marks and you can write the magic. So the magic commands will be shown here. So you have a bunch of magic commands available. So we'll start with some HTML, right? So HTML, we'll see. I'll just type an HTML code. Let's say um, heading two. So you know these heading tags, I guess, in HTML. This is heading two. This is okay. So I think all of you are familiar with HTML. I hope so. I'm not sure. So this is basically an HTML tag, right? Right. So if I run this, okay, you can see the HTML output. See, HTML also works here, which is very nice. So you can work with different types of languages in this Google Colab notebook platform, right? So this is some beauty of Google Colab. So you can rename your file here on top when you click here. So you can say, also say Colab basics, right? So you can rename the file here, and you have many commands available here. The file you can do save your notebook file to your computer. You can upload a notebook, open a new notebook, and those things. You can edit the cells. You can insert new cells. You can change the runtime, and so on. Right. So whenever you start with Google Colab, this is the programming environment I showed you. You can write the code or you can write the text in these blocks. So whenever you want to add a new block, you can either add from this. You can click on code or you can click on text to add a new block. Right. So the important part here is you have something called the RAM and the disk. So you can see here, if I go here, you see you are given zero point 0.9 GB of RAM and 12.6 GB of hard disk. So this is automatically given to you, right? But the most important thing is, as I told you, it gives you free GPU service, right? So to basically work with a GPU, you should go to this option called runtime and then go to manage, change runtime type, change runtime type. So go to runtime and change runtime type, and then you can choose the GPU, right? So what happens is you have a T4 GPU. So you can search what this T4 GPU is. This is a very powerful GPU. So you can basically have free GPU resources, which is very nice, right? So you get free access to GPU resources. So once you click on that, you get a free GPU, and now you can use the GPU. It'll restart your runtime here. You can see it's connecting again, and now you'll be connected to a GPU, not a CPU, a GPU. So this is the most important thing in Google Colab. Now you are connected to a GPU platform, right? A GPU graphics processing unit, right? So that is the most important thing of using Google Colab for machine learning tasks. You have the access to free GPU service, right? And then in the left-hand corner, you have this folder icon. When you click on the folder icon, click on these two dots. So the root folder will be the content folder. Remember, in Google Colab, every data that you want to work with should go inside the content folder. That's where you start, right? The root folder will be the content folder. So as I told you, you can work with many types of languages in Google Colab. So all the Linux commands will work in Google Colab. That's the other beauty of Google Colab. All Linux commands will work in Google Colab. So if I just, so to write a Linux command, you have to start with the exclamation mark, and you can then type the appropriate Linux command. So I'll just type a command to print the working directory, and now it shows me /content. So you can see the content folder will be the root folder of Google Colab, right? Okay. So this is the beauty of working with a cloud service such as Google Colab. You can do your machine learning or deep learning tasks using Google Colab very easily here, right? So I think you got a brief understanding of how to start with Google Colab. So today, all the example I'm going to basically show you will be done in Google Colab. Okay, right. So now we'll go back to our present the yeah, I think it has finished installing. Yeah, so this is the environment that I created now. So you can see if I basically do conda env list again now. So my name of my environment was new environment. Now you can see new environment here. It is created here, right? So now you have the new environment created for you. And now to activate the environment, you have to give the command conda activate and then say new environment, the same name, right? Name of the environment. And once you activate the environment, you can see earlier it was base, now it's new environment. Now you have basically activated the environment and gone inside the new environment. Now you can install all the libraries here. It will only be installed to this environment only, not to other environments. So now you can easily work on a project using this environment. Okay, so I hope you understood that. So start by installing Anaconda or Miniconda, and then you have this command prompt, Anaconda prompt. Go to that, create a new environment, and then you can install all the libraries that you want for your project using this environment, right? This is how you can start on a machine learning or deep learning project in your local machine, right? Right. So if you are starting with machine learning tasks, there are many machine learning algorithms which are available. You have to learn as well. And so you have regression, you have classification type algorithms, you have support vector machines, k nearest neighbor, random forest. Many algorithms are available. So if you want to work with these algorithms, you don't need to have to you don't have to basically write the code by yourself. It is already created for you. All these algorithms are available in a library called scikit-learn. So Python has a library for machine learning called scikit-learn. So this scikit-learn library has all these algorithms so that you can just use them without writing the program or code by yourself, right? So you can go to the scikit-learn website here and you can install scikit-learn very easily using the Python package manager or the Anaconda package manager, right? So all the information about scikit-learn is given here, right? You can see all those information. So very easily you can do this, right? So to install scikit-learn, the command is pip install -u scikit-learn if you are using the Python package manager. And similarly, just as I said, you can use the Anaconda package manager as well. So for that, there's separate command. You see, conda create -n sklearn. So there's a command for conda as well, right? So the beauty of having an Anaconda package manager is the Python package manager is installed by default, right? So if you install Anaconda or Miniconda, you get the Python package manager as well. So I can use the Python package manager commands in my Anaconda prompt as well. So I use this to install now. So I'm going to just install this here. You can see I'll go here. Let me show you. So I'm going to simply install this scikit-learn using the Python package manager. So I'm in my new environment, new Anaconda environment, and I'm going to install this scikit-learn to that environment, right? So once I give this command, it will install all the necessary tools for this scikit-learn package, and then you can use scikit-learn with very easily in your applications, right? So this is how you get started with different machine learning type applications in your local machine, right? So it will keep downloading all the data, and it will basically finish installing the scikit-learn library in your computer, right? So I hope you understood that this is how you can start setting up your environment in your local computer. But today I'm not going to use the local machine, I'm going to use the Google Colab, right? So we'll jump into the example that I'm going to discuss with you. So this is a simple linear regression example, right? So just as I explained, I'm going to do a simple linear regression example in machine learning to show you how you can use machine learning to do day-to-day tasks, right? Okay, so we'll start. Right. So in any machine learning task, you start by importing the libraries, right? So I have imported specific libraries. You have the pandas library, the numpy library. So this pandas and numpy. So pandas library is basically a library to work with data in data science. So you have the ability of working with data frames and working with tabular data. So whenever you want to work with tabular data, pandas is a very good library that is there in Python, right? And when you want to work with matrices, right, or n-dimension matrices, right, different types of matrices, NumPy is a very good library to work with matrices type data. So you can do all these matrix calculations and everything using NumPy library, right? And then Matplotlib and Seaborn, these two libraries are for plotting graphs. So whenever you want to plot different types of graphs, charts, bar charts, pie charts, line charts, different kinds of graphs, you can use this Matplotlib or Seaborn library, right? And then these libraries, as you can see, sklearn is called the scikit-learn library that I told you. So this has all the necessary tools for machine learning. So I have this linear regression algorithm, which is coming from the scikit-learn library. So I'm going to use this linear regression algorithm today. I'm not going to code it by myself, right? You can simply use this linear regression algorithm in your code and you can work with that. It's very easy, right? So you can use the scikit-learn library to get started with your machine learning tasks. Okay, right. So first part is I'm going to load the data into my program. So to load the data, you have a function in pandas called read CSV to read a CSV file, a comma separated file. So basically you have the ability of reading Excel files, CSV files, Word files, or text files. You can read any type of file by using this pandas library, right? So here I have basically read a CSV file called salary data, right? Now, let me first run this code block. So I'll import the libraries first. So to run this code, you can click on this plus the play button, or you can basically press the keyboard shortcut Control and Enter. And then it will run this code block for you. If it ran successfully, there will be a green color tick appearing in this place, right? Just near the plus button, right? So we'll see, still running. So when you run it in for the first time, it will take a little bit of time because it starts your Colab machine, the external machine. And now you can see it has run successfully. You can see this green color tick, right? So this code block has run successfully. Now, if I run this code block now, you will see I get an error, right? Because it says file not found. So I told you the root folder in Colab is the content directory. So if I go to this content directory now, you can see there is no file here. There is no file called self-data.csv. So whenever you do machine learning or deep learning tasks, you need to load the data to your Colab interface. To do load your data, you can simply drag and drop your files to this folder, right? Content folder. So I'll just drag and drop this salary data.csv file that I have in my computer to this content folder, right? So I'll do that. Right. So I think I will be given all this content. I have shared this. So once you get this data, there will be a file called salary data here. If you can see, I'll just zoom in for you. So you have this file called salary data. Simply drag and drop this salary data file to this content folder, right? The content folder. And then you can see once you do that, it will upload the file. And now you can see the salary data.csv file is here, right? So now I have simply added the file to my Colab interface, right? So now this code block, I'll run it again. Now you can see it will run without any error, right? Take a little bit of time, but it will run. So it will run now, right? So now it will search for the salary data.csv file, and you can see it has run successfully, right? So if you open this salary data.csv file, I'll just double click on it. You can see the contents of this file, right? So it will open the salary.csv file. You can see the contents of this file. So it will open it. Let's see. You can see the data here itself, right? It's the beauty of Colab. You can open the file here itself. It will take some time based on your uh, connection, right? Internet connection and everything, right? Let's see. So if it's a very large file, it'll take a little bit of time. So this is a little bit of a large Excel file. It has a lot of data. So it will take a little bit of time to load. So we'll see. Right. As you can see, you have basically this salary data.csv file has two columns. You have years of experience, the years experience, and you have salary. So two columns, the years of experience and salary. So this is basically based on the number of years of experience, the amount of salary that you have to get is basically the data that I have, right? So in this file, I have the years of experience and the corresponding salary for the appropriate year of experience. So it's the years of experience 1.1, this will be the salary. It is 1.3, this will be the salary. So on, I have this data, right? Okay. So that's the data that I have in my salary data.csv file. Now, if I come here, there's a command called head in the pandas library that will show the first 10 rows of your data. The first 10 rows, the first 10 rows here, the first 10 rows will be shown by this command called head. This is coming from the pandas library. So I'll run this and you can see it shows me the first 10 rows, years of experience and salary, right? So this head command, no, it basically shows not the first, not the 10 rows, the first 5 rows, right? Sorry, it shows the first 5 rows, right? So if you want the first 5 rows of your data, you can use the head command. If you want the last 5 rows of your data, starting from the end, you can give the tail command, right? So there are different commands in pandas library. You can go and see. So the tail command will give the last 5 rows, right? So you can see the last 5 rows here, right? So this is how you can just visualize your data, what kind of data you have in tabular format. So this head and tail command is used to give the first 5 and the last 5 rows of your data, right? Okay. So we first basically imported the libraries, we loaded our data file, and now we have just seen what are the data that you have in your file, right? Next, you have this command called def.shape. This shape will show you the number of rows and columns that are available in your tabular data format, right? So how many rows and how many columns are there in your data set? So currently in my data set, I have 30 rows and 2 columns, right? 30 rows and 2 columns. So 2 columns are years of experience and salary, right? Right. Next, now, whenever you do a machine learning task, there are some important steps that you should follow, right? So this is like this. First of all, this is the pipeline that you should follow whenever you do a machine learning task. There'll be a certain pipeline that you should follow. So this is the pipeline. You start with data collection, right? You start with data collection. You need to collect the data. So you have to have a data set with you to start. Without a data set, you can't do anything. So you should collect your data. Either you can download data from the internet or you can create your own data set, right? You can do that. So start with data collection. And then you have to do something called data pre-processing or data cleaning. So you can't just collect some data and just basically put that data into a machine learning algorithm and expect a good result, because your data will not be accurate, right? When you just collect data, it's not going to be in the appropriate format. There can be errors, there can be null values, there can be empty items, there can be unwanted columns, right? Unwanted columns of data. So you might not need all those data. So if you use everything to do kind of a prediction, your result will be wrong, right? So if you want an accurate result, you should first process your data into a specific format. You should remove the unwanted columns. You should basically remove the null values, right? You should do some other things. You have to basically balance your data set, right? If it has unbalanced data, you should balance your data set and make sure your data is properly formatted and properly processed for the machine learning algorithm so that it can make a very accurate result, right? So that is the most important thing. This data pre-processing part is a very important part in machine learning. So mostly what happens is when you start off with machine learning, people just think, okay, you have some data, you input those data into an algorithm and you get a result. That will not be the case. You should first make sure you process your data, clean your data in a way that it will basically be processed enough that your data to get a good result in the end. So if you want a very accurate result, an accurate prediction, your data must be processed well. So this is a very important step in machine learning, right? So you process your data, and then once you process, you feed that data into a algorithm, a machine learning algorithm, and you train your data. So you train your data using a machine learning algorithm, and it will basically extract the necessary features, and it will learn from the features, and it will learn from the variables, and it will try to make a prediction. So what is the prediction it's going to make? For example, in our case, I have 2 columns, years of experience and salary. So when I give this kind of data, it's going to learn a mapping between the years of experience and salary. it will try to map the correlation between the years of experience and salary. And so it will learn, okay, when the years of experience is a certain value, what kind of value should be the salary? It will basically learn that the correlation between the two variables, right? So that is the part. After you train your data, you basically create a file called a model file with some mathematical data in it. We call them weights. So there are many things you have to learn about this. If I go into details, I'm going to go into detail of how to do this. So you create the model. So after you train your data, you create a model, which is a file. So you'll have that file. That file will have all the most accurate mathematical data in your file, and it will have all the predictions, the most accurate prediction. So using this model, you can finally make a prediction on your data, a new prediction. Make a prediction, right? So these will be the steps that you follow in any machine learning task. This is the pipeline. You start with collecting some data, then you pre-process the data, you clean the data. So what do you mean by cleaning? You basically remove unwanted columns in your tabular dataset. If you have a tabular dataset, you remove the unwanted columns. You remove null values. If you have some null values in your data, you remove them, right? And then you try to balance your dataset and you do all this processing and try to make it in a format that is basically good for training, right? So you build and try to format your data in a format that it's basically going to be much better accurate than normal, right? So after you do that, you use a machine learning algorithm to train your data. And after it trains for a while and it trains for a certain number of times, it will create a file called a model file. And using that model, you can make a prediction, right? So that is basically the pipeline of machine learning. So even if this is even for deep learning, this is the same kind of pipeline that you have. So people use these terms in different ways. So the simplest idea that I can give you, the explanation of that I can give you, if someone asks you what is the difference between machine learning and deep learning, these two terms are used a lot these days. So basically, if your data is simple, like textual data, numerical data, tabular format data, then you can use machine learning algorithms to do some prediction. But if your data is complex, for example, if your data has images, videos, things like that, then you can't use normal machine learning algorithms to basically make predictions. You need something called deep learning algorithms like neural networks, different types of deep learning algorithms which are available. So whenever your data is complex, like images or videos, you go for deep learning. But if your data is simple, like tabular data with numeric data and textual data, then you can go for machine learning algorithms, right? That's the simplest kind of explanation you can have. So it's the same pipeline is followed in both machine learning and deep learning problems, right? Okay, so I hope you understood that. So now we have the data collection part is done. We have loaded our data to the application. So we have to do the data pre-processing part. So pre-processing your data, this is a separate area that is basically discussed in data science. This data pre-processing is called exploratory data analysis. Exploratory data analysis, right? Data analysis. This is a very common and popular method that's used. So what you do is this is called EDA for shortened form, right? This is done a lot in data science. So this is coming under data pre-processing, where you basically make inferences on your data. You try to clean your data, remove unwanted columns, remove the null values, use some graphs to analyze your data and see how your data is, whether your data is balanced, right? For example, let's say you have two classes, cats and dogs. Let's say you have 100 images of cats, 20 images of dogs. Then it's basically unbalanced, right? Then if you make a prediction, it will predict cats more and dogs less because you have less number of images for dogs. So you should have kind of a very balanced data set, right? So those things have to be done. So you have many things you can do in expert data analysis. You draw graphs, you draw charts, you basically make some mathematical statistical inferences like standard deviation, variance. You calculate all those things, and see the mean of your data, and you try to basically create your data set in a way that it will be more accurate for prediction, right? So this explorative data analysis part is very important part in both machine learning, in any machine learning task, right? So this is done a lot in data science related applications. So if you are doing any machine learning task, this part is very important. This explorative data analysis part, it will make sure that you understand your data well, and you basically make your data in a format that's much better to work with, right? Okay. So now we are going to see how we can do that explorative data analysis part. So first, what we are going to do is we are going to check whether our data has any null values. So to check whether our data has any null values, we use this function called isNull. It is available in pandas again, and see whether there's any null values in our data. So if you get the output as true, that means your data has null values. So if your data has null values, it's a problem, because then your algorithm will predict wrong results. So make sure whenever you feed data into a machine learning algorithm, you should try to make sure that your data doesn't have any null values, right? Okay. So whenever you run this, if you get true, then it's a problem. So my dataset right now doesn't have any null values, which is good. So then we can move further, right? Okay. Right. The next part. So the next part is, now, whenever you do this machine learning task, you have this part where you split your data into two parts, training and testing. So what you do there is, before you train your data, there is a part called splitting, right? So splitting your data. What do you mean by splitting is, it's like this. Now, what we do here is, for example, let me take the same example earlier. Now, let's say I have basically a data set with 30 rows and 2 columns, just like what I have in my data set right now, right? So let's say here in our example, I have 30 rows, right? 30 rows and 2 columns. 30 rows and 2 columns, right? 2 columns. So what I'm going to do is, I'm not going to use the whole data set for training, right? Normally what we do is, we don't use the whole data set as it is to train. We split the data set into two parts called training and testing, right? So what we do is, whenever you have a data set, we split our data set into two parts. One part is we use for training, the other part is used for testing. So I'll explain what this is. Now, the simplest explanation I could give you is, I'll go back to the cat and dog recognition example so that you can understand better, right? So what I'm going to do here is, let me just remove this for now. Right. So let's go to the example of cats and dogs. So let's say you have a data set where you have, let's say, 50 images of cats, right? 50 images of cats and 50 images of dogs. So you have 100 images, 50 cats and 50 dogs, right? This is your data set. So you don't use all these 100 images for training. What you do here is, you are going to basically split this data before training, and before basically sending this data into a machine learning algorithm. You split this data into two parts called training and testing. So one part you use for the training process, and the other part you use for the prediction or the testing process. So how you split this is, there is a standard percentage metric that you normally can split this data. So if your data set is large enough, we normally split our data set like this: 80% for training and 20% for testing, right? So if it's like a ratio, we normally say it's like this: two thirds for training and 1/3 for testing, right? That's the normal metric or the splitting ratio that we take. This can vary according to different reasons, right? If your data set is very small, then you don't do this. Then you have 70-30 and different splits. You can change the number of splits as well. This is just a standard splitting ratio that is basically used by many people. So this is a standard, right? If your data set is very large, you normally have 1/3, you split your 1/3 of your data for testing and 2/3 for training. So if you have, for example, if I have 50 cats and 50 dogs, I might take like this, for example, 40, right? 40 cat images and 40 dog images for training, and the rest 10 cat images and 10 dog images for testing, right? So I have 80 images for training, 20 images for testing, right? So that's how I will split my data. So what happens is there are 10 cat images and 10 dog images that you will not use for training, but you will build a model by using this 40 images, and you will test that model on the 10 images to see whether your model works properly. That's how you do it. You split your data into training and testing. You create the model using the training data, and after you create the model, you test it in your test data, and you see whether your model works properly. So if your model can accurately classify all the 10 cats and 10 dogs as cat and dog, that means your model is accurate, right? So this 10 cats and 10 dogs, they are not used for the training part. They are only for testing, right? So you have two parts, training and testing. You use 2/3 for training, 1/3 for testing. That's how you normally split your data, right? So remember this. Any machine learning task, you will do this. Whenever you have a data set, you split your data into 1/3 for testing, 2/3 for training, right? So if you have tabular data, so I have 30 columns, right? 30 columns, sorry, 30 rows and 2 columns. So what I'm going to do is I'm going to take 20 rows for training, 10 rows for testing, something like that, right? So 1/3 for testing and 2/3 for training, right? I hope you understood that. So if before you apply a machine learning algorithm, we split our data into testing and training, two parts. So 2/3 for training and 1/3 for testing. I hope you could understand that, right? So that's what we're going to do next, right? In our next part. So simply I'm going to split this data. So here I have split it as test data 0.2, that means two-thirds, I mean 1/3, so 20%. And then the rest 80% will be training, right? This is how you do it using this command train test split is available. This train test split, where does this come from? That's the other thing. So this comes from the scikit-learn library. So if I go up again here, you can see train test split. This module is basically coming from the scikit-learn library. So you don't have to code this by yourself. It automatically has a function that can easily separate your data into training and testing, right? That's the beauty of using the scikit-learn algorithm. So I'll run this now. And when I run this, it will separate my data into training and testing. And then I'll copy my training set into a separate list, kind of a list. We call them a data frame. And then you can see the size of that. Now you have 24. Earlier I had 30, right? Now 24 out of 30 is used for training, and the rest 6 is used for testing, right? So 24 is used for training, and the rest of the 6 rows are used for testing, okay? So I'll see my training data now. So you can see this is the training data. It has taken some random columns, years of experience and salary. You can see some random columns here, right? Right. So this is how you do it. So what you do it, you first load your data, then you see what your data looks like, right? Visualize it in tabular format, and then see the shape. And now you see whether there are any null values, and then you split your data into train and test. Okay. Right. The next part is the important part we talked about, the exploratory data analysis. So in this exploratory data analysis, we see whether our data has any errors. So any unwanted columns, unwanted rows, unwanted values, right? There can be outliers. There can be some outlier values. If there are outlier values, we remove them. Otherwise, our results will be not accurate. So to do that, we can describe the data. So there's this command, the function called describe, which is again available in the pandas library. So when you use this describe command, it's going to describe your data in statistical format. So then you can see the mean of your data, median of your data, standard deviation, variance, all these statistical functions will be carried out in this describe function, right? So when you describe your data, you can see all these data. So related to your column. So this here you can see the count, the mean, the standard deviation, minimum value, the first percentile, second percentile, third percentile, max value. All these statistical information will be given using this describe function. So once you do this, you can get an idea of what your data is like, right? Whether your data is balanced, the data has any wrong values. You can see all this using this statistical analysis, right? So do that, you can use the describe function, right? The next one is now in this is a regression problem, as I told you earlier. What we are going to do is we are going to see whether the two variables, number of the years of experience and the salary, are basically going to correlate or basically have a mapping between each other, right? So what we normally we're going to do is it's like this. Now in this example, now I have two values, the x and y, right? So here in this example, so I have two axes, x and y. So I have the years of experience in my as my y, years of experience, and salary as my x, right? This can basically be the other way around. It doesn't matter, right? You can have a salary for the y-axis and the years of experience for the x-axis. As long as you have only two variables, it's fine. But if you have more than two variables, then you have to be very careful of what are the x and what is the y, what is the target variable, and what is the other predicted variable. But when you have only two variables, it's fine, right? You have to just see the mapping between these two variables. So you can interchange between x and y if it's just two variables, right? So what we're going to do is there might be different values, right? For different salaries, you have different values. So I'm just going to plot some points here. So these points will say for specific salary, what's the year? So I'll change this so that it's much more better. So I'll change the X and Y for you. It will make much more easy to understand. Right? So let me change it. Right. So here, let me do this as well. Okay. Right. So I'll say this Y. I'll take the Y-axis as salary. This as salary, and X as years of experience. And now I have plot some points where I have a mapping. So for specific year of experience, the years of experience, I had salary. So here for a specific year of experience, I will have the salary, right? So I have different points. What I'm going to do is I'm going to see the correlation, how these two variables correlate with each other. If the correlation is high, then I can basically draw a best fit line to basically map these two variables. So what do you mean by a best fit line? Is a line that goes through the most number of points, right? So you have, and you can understand that. So a straight line, right? I haven't drawn a straight line. You should draw a straight line, right? Let me draw a straight line. So it's basically you're going to try to draw the best fit line that goes through most number of points. So that will be the best fit where it have the best correlation between these two variables. What do you mean by the correlation? Whether these two variables relate with each other. If you don't have variables that relate with each other, you can't do the regression analysis. You can't use regression for machine learning. Then it will not work, right? Then if these two variables are not going to have any relation at all, then you can't check for any mapping. That will not work. So for this to work, your two variables should correlate with each other, right? So that's why where you need to check whether these variables correlate with each other. For that, you have this command called correlate. So when you see that, you can see the correlation between the salary and years of experience. As you can see, the correlation is very high, 0.9 and 1. So 0.98 means these two variables correlate with each other very well. That means we can find basically a good relationship between the two variables. So now we can draw a graph to plot the points for different salaries and different years of experiences, right? So in my data set, I have different values for years of experience and salary. So I'm going to plot that in a graph, right? So let me run these two lines, the correlation and the graph. So you can see now it has plotted my values in a scatter plot. This is called a scatter plot where you have different points. So you can see salary as the y-axis and years of experience as the x-axis. So for a specific year of experience, you can see the salary, right? Now the next step, what I'm going to do is I'm going to try to draw the best fit, the line that can go through most number of points, the best fit, the most accurate uh, relationship, the mapping between these two variables. So using that best fit line equation, now if I find that, after that I can simply use that equation to predict a salary for a given year of experience, right? So now I'm going to do that. For that you have this reg plot, the regression plot, which is coming from the Seaborn library for drawing graphs. So you can just give the two variables and it will draw the best fit for you, right? So you can see after you do this, okay. Um, you see. Smaller. Right, so let me see what's some. Okay, let me just copy this. Right. Salary is this. Okay. Let's see what's the problem. TF. Okay, right. Right. Mm, let's see what's the problem here. Okay, this is fine. Okay. Let me give this TF. Okay, okay, the problem. Right, we'll give him the inputs as salary. Mhm. Mm, right, let me open the file again. Right. So next part, what we can do is we're basically going to find the best fit line. So this red part will work, right? Let's see what's the problem here. So after that, it will basically plot you the best line, the best fit line. And then you can use that line to basically make a prediction, right? So we'll see what's the problem here. Yeah, close this. Open a new file. Right. Right. Okay. So let me run this and see. Right. So here you can see the line of best fit will be drawn after you run this code, right? And then it will basically go through the most number of points. So once you have this line, you can easily predict for any year of experience the corresponding salary, right? So the next part will be to predict any. So you can give any value for year of experience. It will automatically predict the price. So let's do that and see what happens. So here you can see when I give my testing data here, it will give you for the corresponding years of experience, it will basically tell you what is the salary. So here for years of experience is 28, the salary will be this. The year of experience 24, the salary will be this. So for any year of experience, it will take the corresponding salary for you, right? So that's going to basically just predict you. You can just input any year of experience after you get the best fit. You can simply do that. So this part is for after this, the model is now created. So we have finished creating the model. Now we're going to predict using the model. So for that, we are just going to just take this data and use the model that we have created and just simply predict the salary using the year of experience, right? So you can do that very easily here. And after you basically predict your results, normally what we do in any machine learning algorithm is we try to check the accuracy of our algorithm. So if our accuracy is not good, then these results might not be accurate. So to check the accuracy, there are some standard metrics available in machine learning. So here you can see we have these accuracy testing algorithm called the R2 score. So there are many metrics available. You have the precision, you have the recall, you have the F1 score, you have mean squared error, root mean squared error. So many types of accuracy metrics available. This is just one accuracy available. So this is the R2 score. So this R2 score will tell you how good or how accurate your current model that you created is. So as you can see, this R2 score here is 0.9, which means it's 90% accurate, which is very good, right? If it is below like 0.5, like 0.3 or 0.4, something like that, then that means your model is not very accurate. Then you have to do something there to change the type of data. Maybe there's a problem with your data, or there can be some problem in your parameters that you train on. So you have to change these things and see. So one thing again I have to say is that these machine learning tasks, these are trial and error, right? You can't just straight away get the best model. That's never going to happen, right? You have to try, you have to retrain your model and see with different parameters. So it's a trial and error thing that you do. Try to get the best fit and the best accuracy possible for a specific data set. So you have to try with different parameters and different data set by doing different data processing for your data and try to see how you can get the best accuracy for your data, right? That's the most important thing. So it's a very trial and error type of a task. You can't just get the result at once, right? So you can see I have plotted the result here, the accuracy. And finally, this is the best plot. So this red color line is the most accurate line, the best fit line that has the highest accuracy for this. So this line will predict the most accurate salary for a given year of experience, right? So this simple example showed you how to basically uh, do a regression type machine learning algorithm where you predict the salary for a year of experience. So what we did, we had a data set, we loaded our data, and then we try to process our data, visualize the data, and then we process our data by seeing what are the null values, and we did some EDA, the expert data analysis, and we try to process the data and see what rows and what columns we have to take. And after that, we split our data into training and testing. So normally we train two-thirds for training and one-third for testing. And we take the training data and we train our model. So we train on that data and we basically learn a mapping between the salary and the year of experience. And we try to draw the best fit line. After we get the best fit line, we can simply easily predict for any year of experience what is the salary. So this is a very simple example of machine learning. So this again can be evolved into other types as well, right? So this is an example for a regression problem because our data is continuous. If this was a classification problem, then we have some classes where you can basically predict a class, for example, whether it's a car or van, it's a cat or a dog, something like that, right? Okay. So that is basically very simple example for machine learning. So I hope you understood that machine learning example. So you can work with many algorithms in the scikit-learn library. So although here I have only used this linear regression, right? But here in this example, I have used linear regression here because it's a regression problem. There are other algorithms available like SVM, support vector machines, random forest, many machine learning algorithms. So the important thing is now when you go to do machine learning, first you have to best understand a little bit of theory as well. These are all statistical and mathematical algorithms available. So just don't apply these algorithms and see what happens. Try to basically search a bit of the background and understand what these algorithms are, the mathematical part of it, and how these work, and get an idea of what these algorithms are before doing it practically. That's the best way to start off with machine learning tasks. So you have to learn the theoretical part first as well, and then get a good idea about what these are, and then go for the practical part. Because otherwise, you'll just be using something. It's like using ChatGPT, right? These days, you just use ChatGPT and you just give a question and expect an answer, which is not the best way to do it. You have to have an idea of what you're actually searching for and what you're asking. So you can't just tell ChatGPT to give me a Python answer and expect it to be right. You have to have an idea of what, how you know of the Python programming language, so that you know whether it's very true or false, or whether it's correct. It's, or sometimes it can be wrong as well, right? So you have to learn about these algorithms as well and the theoretical part of it. So when you go to this scikit-learn library, there are many examples which covers many algorithms, right? So you can see you have many types, classification examples, regression examples. You have many examples. So I'll just go for a classification example. So you can just check these things out. So it's very easy. It has all these examples given to you, right? For example, I'll give you a classification. So the example here. So you can just go here and see all the codes and work with them very easily, right? So here you can see the code is also given to you, which is very nice. You can just copy this to Google Colab, run and see this and see how you can get the results. So go to the scikit-learn website and install this and work with the examples and see how these different kinds of classification and regression machine learning problems work. And while you are doing that, just try to learn a little bit of theory of what these algorithms are and how the mathematical and statistical part of it work. Right? So this regression is simply a very basic algorithm where you try to plot a line that basically covers the best fit, that basically correlates the two variables x and y, and try to map those two variables and see after you plot the best fit line, then you can simply predict the appropriate y for a given x. So it's like a y equal mx plus c, right? So this once you uh, plot this line, once you plot this line, this is like this line is, the equation is y equals mx plus c. So for any x, you can see what's the y depending on this, right? So it's very, so that's basically a very simple example. So the part of this is when you take this to some artificial intelligence based application. Let's say you have web application where you insert the years of experience, it will basically output you the salary. So that's like it happens automatically. So that's kind of the artificial part of it. So you see this happening automatically. You don't need to do anything again. It automatically predicts the result. Once you create the model, it predicts you the result for new data. That is the beauty of these kinds of applications. And that is what how all these applications work, right? So I'll show you a simple, so after this, I think this basically covers the machine learning example. So as I have a little bit more time, I'll show you a simple deep learning example as well. just so that you get an idea of what that is and how you can work with it. So I told you I work with this concept called style transfer. So I'm going to show you a very simple example of style transfer and how you can do style transfer with this Google Colab, right? So let me go to that. Okay, I'll go to this and I'll open that notebook. Right. Okay. So we'll see. Yes. So this is a deep learning example. This is not machine learning because it works with images, right? So this is kind of a deep learning example I have. So as you can see here as well, I'll first connect here to a GPU because it needs some high processing power. So as you can see here, just like before, I'm importing the libraries first. The first task is to import the libraries. So one of the most common libraries available for deep learning is TensorFlow. We have two very common popular libraries for deep learning called PyTorch and TensorFlow. TensorFlow is a very popular library for deep learning in Python. So I have imported TensorFlow here, right? And then Matplotlib again and NumPy, just like before, right? And here, what I'm going to do is I'll first run this. Okay. Right. So now what I'm going to do is I'm going to basically run this code where I can simply input an image. So I have taken some image from Wikipedia just for reference. So I'll run this easily, and then you can see the image that I have basically downloaded from Wikipedia. So, right, so it will download the image and show. Right. Okay. So here I have two images that I've taken from Wikipedia. The content image is this and the style image is this. So what I'm going to do is I'm simply going to add this style, the one on the right side, to the left content image, so that this content image will have the similar style to this style image, right? So once it's applied, you can see how it is, right? So I have two images, the content image and style image. So using something called a neural network, I'm going to basically extract features from the content and from the style, and I'm going to basically combine those features and create a new image where this new image will have the style similar to this style image, right? That's what I'm going to do. Okay. So we'll see that. For that, this TensorFlow has some existing functions that you can use for stylization, where you don't have to create neural networks by yourself. You can just simply use this. So for simplicity, I'll just use that. So now we'll see how this style transfer works, right? So after, it will take some time to apply the style. It will extract the features and apply the style. And then finally, when you visualize the image, you can see how the style is applied, right? So it will take some time to apply the styles, and it will first extract the features from the content and the style image, and finally it will apply the style. So now you can see here, look at this. You have the content image, you have the style image, and on the right side you can see after applying the style how it looks. See, the beauty of this is now at a glance, someone can think, okay, why can't I do this manually? For example, people that does Photoshop and other image editing tools, but people that are good with these image editing tools, they'll say, okay, I can do the same thing in Photoshop. Why use deep learning? Now, the thing that you can see very clearly here is if you do this manually, it's a very difficult task. Why? As you can see here, you have these features of this image. They are not distorted. See, you still can see the bridge, the edges, and all these edges here. They are still very visible, but the style is also applied at the same time. If you try to do this manually by yourself, it's going to be a very hectic task and it's going to take a lot of time, and you might not have this kind of accuracy if you do it. See? And then what happens is if you do it manually, you might not see the bridge anymore. You'll just see something else, right? You will not see the bridge. But here you can see the bridge is still visible. See, even the minor details of the bridge, it's still there. And it will not basically destroy the features. It will keep those features and it will add the style features when those features are still there. So that's the beauty of this. So these are some of the things that you can do with deep learning and things, right? So you can see these are very interesting stuff. So nowadays these are used for visual effects and other things, and these are so to do this we use simply, so what we do is we learn from these two images we extract the features like the brush strokes, the color pixels, the brightness, the contrast. All this information will be extracted, and then we'll basically combine those components together to create a new image. And that's basically going to apply those styles here to this image and create this final stylized image, right? So we can see some other examples as well, right? We'll just go and see some other examples. It'll download some other images just to make sure you understand this better and just to see it clearly. So this, I think, shows you clearly, right? So we'll see some other examples. So it'll run, it'll take some time to extract features and combine and show you the final result. You see? Right, you can see here, yes, a original image of a turtle, and then there's a style image. And once you apply this style on the turtle, you can see on the right side, right corner, you have the stylized image, right? So that's how you can do it. So you see, you can, this turtle, even the most sensitive information, the strokes and the edges and the corners are still visible. And it's that's the beauty of using this, other than doing it manually. If you do it in manually, you might not see the turtle anymore. So these are things that you can do, right? So it is the example of style transfer, how you can do style transfer using this deep learning algorithms, right? So you have these neural networks, something called neural networks, which is kind of a big the topic to discuss on a later date. But you can go and find out these things, and for now, so you can start off and see how you can work with these kinds of applications, right? And finally, I will show you another deep learning application, which is an object detection example, so that how you can detect objects in an image, right? So let me show you that as well. Right. Right. So just like before, we start off with importing the libraries. So for this also, I am using TensorFlow like before. So let me start by importing the libraries, and I'll just run this code, right? Next, I'm going to basically take some already built models. So there are things called pre-trained models. So what do you mean by pre-trained models is, now earlier we created a model by ourselves, right? For the regression problem, we created a model by ourselves. But there are some models which you can use, which are already created for you. For example, when you want to do things like object detection, there are models that are already created for you, which are basically tested on very large data, right? So like millions of data, there are people that have made some models by basically uh, training that those on very large amounts of data. So they are freely available for you to download. You can just download those models and use in your own data, right? So what we do is we train our data on top of the already trained model, which will be more accurate, right? Rather than doing it from scratch, using an already trained model will give you much higher accuracy. So that's one of the things that you can do. So you can find out there are many already existing models that are there for object detection, right? So I'm using a certain model for object detection, right? Okay, let me run this. Okay, right. So let me just run this code and show you what happens. Right. Okay. I'm loading the model that I basically downloaded. It will load the model. It will take a little bit of time to load the model. So it's loading the model currently. So these models can vary. So there are some large models. It can some, the model size can be large. So some models might be very large files. So it will take some time to load those models. So based on the type of model that you're loading, it will take some time, right? So once you load the model, you can use that model to predict, or you can do detect objects. In this case, we are trying to use this model to detect objects in an image, for example, people and other things, right, in an image. So you can see how we can do that. So it's still loading the model. Okay, it has loaded now. Now I'll load an image, right, a sample image of some people in a beach, right? So you can see. So what I'm going to do is I'm going to use this image to predict or to detect the objects that are there in this image. For example, the people and the other objects, right? So we will first load the image and see. Okay. Right. So you can see this is the image that I'm using here. So it's an image of people in a beach. You have some people there. You have some kites like things. Yeah, kites. So I mean, these not kites actually. These are like the surfing things, right? Surfing of equipment. So those are there. So what I'm going to do is I'm going to use this image to basically detect these objects that you see on the image, right? So for that, we are using the TensorFlow Object Detection API. So you have an object detection API that's given by TensorFlow. You can just use it to detect objects by configuring the parameters easily. But before using that, you need to learn how you can do object detection and the concepts, the theoretical concept behind that. So after that, you can basically use these kinds of APIs that are given to you. But first, you need to learn the theoretical concepts as well, right? So now what we're going to do here is now, once you train a model, it'll recognize these objects, right, in your image. It will draw bounding boxes. It will draw bounding boxes for each of these objects, and it'll give a label, a name. For example, it'll draw a bounding box for this person, and it'll have a label called person. So how do you do object detection is, you have to have a set of images and you have to annotate the images. What do you mean by annotating? You need to label the images by yourself. It can be done manually, and we have some software for it as well. So you draw bounding boxes by yourself and you give a label, right? And then you'll have images with labels. Once you train it using an algorithm, the algorithm will basically train and understand, okay, these are the objects, which are the coordinates of the object, and also the label of the object. Once it learns that, when you give a new image, it will basically automatically draw the bounding box and label the image. If it has a good accuracy, it will draw the bounding box and label the appropriate label for the image. For example, it will label this person as a person, right? So we'll see how we can do that. We'll run this. So it will run the model and the algorithm on the image, and it will finally show you the label, right? It will detect the objects like on the image using the bounding boxes. Right, we're still running. You see? So depending on the type of image and the size of the image, the size of the model, it will take some time. Right. So now you can see here these bounding boxes. It has basically detected, see, the person, the kite, right? The kites, the surfboards. It detected all these objects very accurately. See? So these are some object detection, how this object detection works. You can see how well and how easy it is to build these kinds of things, right? This is the same concept used in Facebook tagging. If you have seen, Facebook tags our photos by drawing a bounding box and giving the name. Right? When you have a photo, it will tag your people automatically. This is the same algorithm that they use for tagging, but it's much more advanced. They have their own uh, code available for them, but same concept. Basically, they use the same concept for Facebook tagging as well, right? Okay, so that's basically what I want to discuss and give you a basic introduction to machine learning. And I have shown you some examples for deep learning as well. So you have to start with these kinds of things and basically explore these things by yourself. So you'll have a task that you have to do as well. And once you do the task, you'll get more experience and more familiar with these concepts. So learn the theoretical concepts as well while doing the practicals, and then you'll get a much better idea of how you can do these things easily. Okay, so that basically concludes my session. So yeah, thank you.
Thank you, sir, for sharing knowledge and make the session much more valuable. Sir, we are ready with a small token of appreciation. Please accept this with our most heartfelt gratitude.
Thank you.
If you have any doubts, you can direct them to Sir by using the chat box, or you can unmute yourself and ask your questions. You will have 10 minutes to ask any subject related matters, and your time starts now.
Yeah, actually, so there's a question. So yeah, you can get the so I will share all these codes and resources for both machine learning and deep learning. I think I already shared this with one of these resource person. So one of the organizing people. So I think yeah, you'll get all the resources. So don't worry. You'll get all these codes. So you can try these codes in Google Colab.
Guys, if you have any doubts, you can direct them to Sir by using the chat box, or you can unmute yourself and ask questions. Once more, Mr. Pramukha Veerasinghe, we are incredibly grateful for your indispensable contributions. Now, I would like to invite Yuvanika Samaravikrama, the project secretary, to deliver the word of thanks. Yuvanika, the virtual stage is yours.
Thank you, Malka. Good evening, everyone. I stand before you today with deep gratitude in my heart to express my sincere thanks for your participation in the InspiHER Tech Question 2 MATLAB sessions. I extend my deep appreciation to our special speaker, Mr. Pramukha Veerasinghe, a lecturer at the Department of Statistics and Computer Science, Faculty of Science at the University of Peradeniya. Sir, your gracious presence and two-day dedication to us are truly appreciated. If any mistake made during your time, please accept our sincere apologies. I would also like to express my appreciation to the advisory committee and the organizing committee for their tireless efforts. ensuring that this Place Run MATLAB session series surpass all expectations. And my beloved participants, I wish to convey my heartfelt thanks for your active engagement and participation as we finish Place Run of our MATLAB session series. Today, I am grateful for the collaborative learning experience we have shared. Once again, I extend my sincere thanks to each and every one of you. And participants, hope to see you all in our phase 2. Thank you.
I'd also like to acknowledge our dedicated team behind the scenes, whose endless effort made this workshop not just possible, but a seamless and informative experience for all. To all the enthusiastic participants here today, your engagement have been the backbone of this workshop success. And finally, to everyone who helped in conceptualizing, organizing, and running InspiHER V2.0, your dedication is truly the wind beneath the wings of this incredible initiative. Thank you once again for joining us today, and may we carry forward the insight and inspiration as we continue on our path to growth and excellence. Before we draw the curtains on today's event, it's picture time. Kindly activate your cameras and dress your backdrops with the virtual scenery provided in the chat. Ready yourself for a snapshot to keep the memory of today alive. A couple of minutes begins now before we capture the memories. A sparkling thank you to all. As for me, Malka Sandareno, I am wrapping up today's session with a content heart and expectant eye towards the future. Stay inspired, and until next time, thank you and take care.